Hey students, in today's video we will talk about our new chapter, that is matter in our surrounding. Okay, now we have a question that what is matter? What is matter? As we look at our surrounding, we see variety of things with different, right, with different size, shape and texture, right? Everything in the universe is made up of matter. The air you breathe, the food you eat, the cloth you wear, everything is made up of matter, right? In this chapter, we shall learn about the physical properties of matter, right? Here we have a point to note that matter are made up of particles. All right, matter are made up of particles. Now we discuss the characteristics of particles. Characteristics of particles. And our first characteristics is that particles of matter have space between them. Okay, space between them. Now I explain this property by an example. Okay, take a glass of water. Take a glass of water and mark the water level by the marker, right? Now add some salt into the water and dissolve the water with spoon. Now what do you observe? Is the water level increase? If no, then where does the salt goes? This phenomenon shows the particle of matter have space between them. Let's suppose this is water, and water have particles. The particle of water have space between them, where the particle of salt dissolve, right? That's why the water level doesn't rise. And our next characteristic is particles of matter are continuously moving, right? Now I explain this with a simple example. Let's suppose you are sitting in a dark room, right? You are sitting in a dark room and there is a window from where the sunlight comes. What do you notice here? The particle of air that see in the light have small particle that moves continuously in zigzag path, right? This shows that particles of matter are continuously moving. All right. Now our next characteristic is particles of matter. Particles of matters are attract each other, right? Now I'll explain this with a simple example. Let's suppose we have a tab here, water tab here, and water stream is coming from the tab. Now try to cut the stream with the help of finger. Are you able to cut the stream with finger? No, because the water particles are attracted toward each other, right? I hope you understand my point. Now, here we have three states of matter. State of matter. And the three states are solid, liquid, and gases, right? Now we learn these state of matter one by one. All right. First, solid, then liquid, then gas. These are particles of solid. You see, the particles of solid are very closely packed. That's why they have negligible space between them. That's why solid have definite shape and definite volume. Definite volume, right? And solids are incompressible. We can't compress the solid. All right. Now we have liquids, right? The particle of liquids are not closely packed. They are loose packed, right? There are some space present between the particle. All right. So we can easily compress liquid. Liquid have definite volume but not definite shape, right? Now suppose you have a glass of water, and you transfer the water into the bowl. Now what do you notice? The shape of the water in the glass change to the shape of bowl. Water can change the shape according to the vessel, right? But Let's suppose we have 100 ml of water in the glass, but the quantity of water remains same in the bowl also, right? We have 100 ml water in the bowl also. So liquid have definite volume but not definite shape, all right? And liquid are compressible in nature. You can easily compress the water by your hand. Now we have gases. Gases have particles randomly moving very far apart. They don't have definite shape nor definite volume. All right. Now let's suppose your mom cooked food in the kitchen, right? The aroma of food reaches to you in few seconds. How? Because the air in the kitchen are moving and reaches to you in your room. So this shows gas don't have definite shape, not definite volume, right? Now we have a question here. Can states, can matter change their states? Can matter change its states? And the answer is yes. Matter can change its states. But how? Let's suppose we have ice. We heat the ice and now we get water, right? And if we further heat the water and we get water vapor, right? So by simple heating, we convert solid to liquid state, then to gas, right? So we can change the state of matter by simple increase the temperature, right? Now there is some effect of temperature on the matter. Let's see effect of temperature on the matter. Effect of temperature. Now let's suppose you have a beaker and you put some plastic rod in the beaker, right? And put the beaker on the burner and start the burner. After some time, what you notice that the plastic rods start melting, right? Melting and convert into liquid, right? So what happened here on increasing the temperature of solids, the kinetic energy of particles start increases. All right, start increasing and particles start vibrating, with speed because they get kinetic energy, so they start vibrating with more speed, and hence result particle leaves their fixed position. All right, now they freely move, right? Freely vibrates. Now at this point, solid starts melting, and the temperature at which solids start melting is called melting point. Melting point. At the temperature at which solids starts melting. All right, similarly, we have a boiling point. Boiling point. Boiling point is the temperature at which liquid starts to boil. All right. Now we have boiling point of water. 100 degrees Celsius, okay? And the melting point of ice is 0 degrees Celsius, right? Now we have some more effects like effect of pressure. Effect of pressure. We can change the state of matter by increasing the temperature. Can we change the state of matter by other way? Like if we have carbon dioxide gas and we apply high pressure, we get dry ice. All right, solid. Now by high pressure, we can also change the state of matter from gas to liquid, like our gas in the cylinder, right? Gas in the cylinder, the particles of gas are away from each other. As we apply the pressure, the particle come closer and gas become liquid in the form of liquid. This is called liquefaction, right? Liquefaction. So we can change the matter from one state to other, right? How? I'll show you this by a simple diagram, right? We have solid, then liquid, then gas. We can convert solid into liquid by heating, and liquid to solid by cooling, liquid to gas by heating, and gas to liquid by cooling, right? Now, is there any process by which we can convert solid directly to gas or gas directly to solid? Yes, as I told you that by pressure, high pressure, we can change carbon dioxide gas to dry ice solid, right? This is the process of deformation. All right, we can change the gas to solid, right? And how we can change the solid to gas? There's a process called sublimation. An example of sublimation is naphthalene ball. All right, naphthalene ball are in solid state and they can directly convert to gas, right? This is called sublimation. Now, I told you that we can convert liquid to gas by heating, right? And solid to liquid by heating. Is there any process by which we can convert liquid to gas but without going to boiling point? Yes, there is a process called evaporation. Evaporation. What is evaporation? Evaporation is the process. Evaporation is the process by which we can convert liquids to gas without reaches to their boiling point, right? Example, we put clothes to dry. All right. Now, there is a interesting effect of evaporation. Evaporation causes cooling. Let's suppose you have a bowl and you pour some water into the bowl and you kept the bowl for 2-3 days. What do you observe? The water started increasing because the evaporation takes place, right? In this process of evaporation, energy of particles gets lower due to evaporation, right? So to overcome this energy, the particles particles regain their energy from surrounding. As a result, surrounding cause cooling, right? Cooling. So cooling is caused during evaporation, right? I hope you understand the all points we further discuss in our next video. Happy learning!